Okay, next up we've got Kim Horton, who's going to be telling us about, do you want to read the title?
Yeah, all right.
It's long.
It's long. All right, so, we're in the wrong place. That's cool. All right, so my name's Kim Horton. I work at the University of Adelaide and I work in marketing and strategic communications. My job in strategic communications is all the web services. So my job is specifically the hardware that people want to virtualize away. And so as Phil was talking before about the hardware of someone else's problem, it's my problem. So I do a lot of Linux sysadmin and a bit of Perl, C and a lot of other stuff. You know, basically I take care of apps on our web apps, our web app platforms. So what this talk is really all about is reliable networking infrastructure for your cloud. So what this is really about is I'm talking about configuration for the servers that actually run the VMs. And part of my job there is very specifically is managing all of that infrastructure below the clouds, then our web app developers and stuff too, all the web apps that sit on top of that. So the VMs that sits on the networks, that sit on the network infrastructure on all of those servers. But it's not just about that. There's a lot more to, redundant and fast network infrastructure. You've got all those NICs and all those servers. You've got many servers if you're going to have any redundancy because you want to have VMs and migrate from one machine to another. And then, of course, you can have multiple data centers. And we have a couple of data centers. We've got a dozen servers that do most of our website infrastructure stuff. And so, there's a lot of network gear between our servers. So there's, core switches, routers, all that fiber between everywhere and everywhere else. A lot of config. That network stuff underneath the server, that's not my problem. But the server, which is the server config, that's what this is about. So, some years ago we started off with a bunch of RHEL 4 boxes and we wanted to modernise all the stuff. We had CGI hell and we wanted to migrate to more modern Perl, more modern web apps. There's a lot of legacy stuff we had. We had some big issues, main one being an ancient Perl and just more latency, more legacy apps and bits and pieces that we're trying to move away from. We were back onto Oracle, which is not my favourite database. We had a whole stack of issues there with latency and lots and lots of things. So we moved on to VMs of RHEL 5 on VMware because that's where the university was going. Very specifically wanted to put things to virtualise lots of things, and it made a lot of sense to us because hey, we could spin up more VMs, we can manage load and all that sort of stuff. However, moving from RHEL 4 to RHEL 5 put us in a dependency hell that we really never expected. We went from 500 CPAN modules to well over 1,000 CPAN modules on RHEL 5 that we actually had to maintain ourselves, and then 1,500 or so RPMs that we had to hand build, and it was a huge amount of work. So the other thing that we found was the VMs on VMware were much, much slower than the physical machines that we had that were now approaching 4 years old, 5 years old. So we had all these extra delays, slower I/O, slower network I/O, and all sorts of other issues going on. And my least favourite database would take seconds to make connections. So when you have a web app and you want it to view like that, you can't wait 3 seconds for a database connection. All these issues. And the other thing we had with RHEL 5 was a really interesting bug of NFS-style file handles. Basically what happened is that you'd open the directory, you'd look at the file, hey, the file's gone. It's not a good look. So we had all sorts of issues in that sort of space. And so we spent a lot of time debugging issues. And so we were thinking at this point, maybe VMs are not for us. Maybe this really isn't where we want to be headed strategically for our long-term web apps, just from a latency point of view alone. Because what we do in MSc is we have the marketing people that tell us this is the direction we want to do with the communications we're going. Okay, all right, so one of their core tenets is web pages must be fast. Every 5 seconds, you lose another 20% of your audience. That's how they think about their website. And so the longer the page ceases to load, the more and more people you lose. It doesn't look good. So this development process took a while, and then Rel 6 came out. We thought, all right, okay, so maybe there's a whole bunch of problems in the Rel 5 kernel. We'll move to Rel 6. We should fix this. But it didn't. We spent a lot of time trying to debug stuff and trying to figure out where all our latency issues were. And it was at this point where we were going, this isn't working for us. We need to talk to our management. And this is where all of the hard stuff was for us. The tech stuff was, we know what we're doing. We have the tech, we go and build stuff. We have these problems, we go back through that cycle of fixing. So we went and talked to our management and said, look, this isn't working for us, especially when after we had a website that was pwned. It was very embarrassing, and it was due to some patches that hadn't been applied yet as part of the Red Hat distro release, and we're pushing out patches quarterly, which just isn't enough if you want to run a public website that's, millions of hits a day and lots of people are interested. And the amount of penetrating testing tools that have been coming out in the last few years, people are running them from all over the world and they're hitting every website, and we see dozens and dozens of these things a day from all over the place, especially the US and China. So, we wanted a much more up-to-date security model where something was done more frequently. We were really, really unhappy with the way VMs worked on VMware, and our disk and network latency was orders of magnitude more than 5-year-old hardware by this point, or 7 on. So we were, basically went back to business to the managers and said, we've got to change. We've got to find money for hardware to buy new gear. And they went, now how about we put stuff in the cloud? And we went, okay. We compared the costs, because everything for us is off-net. We use ARNet, but we pay for traffic that goes off-net. And we looked at the volume of traffic that we do, terabytes a week in terms of web traffic. It just wasn't affordable for us to do at that time. So we made a business case, we bought new hardware. So we spec up new machines, we buy new machines. That takes a while in the slow business process at the university. We go through, we deploy Debian because it's got a faster, specifically Debian because it includes all the packages that we need. We don't have to package stuff by hand. The release cycle for security updates is much, much faster. All of the, specifically the VLAN and the bonded Ethernet tools are all there by default. You don't have to build anything. We want to do specific dev UAT, sorry, UAT is user acceptance testing. So we have a dev where we work, we have a testing layer for where our other staff go out and talk to all of the people on campus, and then we have a production environment. So we have these 3 environments, nice and well staged. We've got a lot of tool and a lot of workflow based around this model. We didn't want to do VMs at all because we were hurting so badly on VMware. So we deploy new servers and we start transferring apps across. Well, yeah. So this little graph, this little line here is why we believe in redundancy. If you can read that, it says the Great Flood of 2005. We have 2 data centres. One of them had 40,000 litres of water go through it. There was a nice little gentleman with a backhoe, went, here's a nice fire main, I'll just, dig through that as I'm doing my excavation work. And so we very literally had our data centre flood, and the university then from that point on went through a whole series of service changes to add redundancy. We went through the whole network stack from the low level up in terms of switchgear and DNS and DHCP and all these other services that were core network stuff. We made sure that there was double links, everything. And so this was kind of part of our big picture as we talk to management, going, we need to have dual redundant web stacks for everything. The whole idea that if we have content, front-end machines, web services, databases, everything. So from our point of view, redundancy was really, really important. And you can see from that graph, there's a reasonable amount of growth over the years. I mean, I'm missing some of that image. All right, so you can see that it says up here 7 million hits a day. Doesn't sound like very much, but we had 4 Deal 380s, quad-core machines, absolutely flogging. Basically, everything about that was waiting on a database. So, and now our growth has been going up a whole lot more since that point. And so, one of the reasons we're embarking on this whole process is our partners in this, the web service component, is the marketing team want to drive lots more traffic to the website. So we had to have the high uptimes, and they were really, really keen on the low latency. So you can see that, you know, even though this only says 7 million hits a day, and it doesn't sound like a great deal, it was really, really important to the way the university works, because the university pulls in money by having students come in the door. And so, you know, without students, without those customers, basically, we don't get money. It's not a business, but, you know, it's the same sort of thing. And so this was becoming really, really important for us, which is why the redundancy was such a big factor. Now, what happens next? Right, so just before Christmas, we got all these dozen servers come in the door, and literally the Christmas day, I spent at home remotely spinning up Debian on all these machines and installing everything, and I thought, there's KVM and QEMU on here, I might have a tinker with that to see what it's like. So I spent pretty much the Christmas holidays tinkering with the first parts of that, of our new VMware our VM infrastructure. And one of the things we do when we get a new machine is we hammer it a fair bit. You know, hammer CPU, hammer memory usage, hammer disk usage. So if we're going to have any failures, we want to know about it straight away before we put these things in production. That's kind of standard procedure for us. And so we'd been using things like DNetC and Bonnie and all of those fun things for years. All right, Mike. So instead of using things like Bonnie and DNetC, we found a new project, which was the Skynet project. It's actually a radio astronomy computing distributed challenge thing, so we did a little bit of that. And so I spent a lot of time spinning up VMs by hand initially, and then scripting stuff after a while to do this distributed computing challenge, and had a bit of fun at that. So anyhow, so in the new year, we came back and we went, right, okay, we've got all these extra challenges we want to do. We want to have all these different Perl environments. So we ended up using Perl Brew, and we're building a single environment. And then we came to our PHP apps and said, right, okay, we need an actual VM stack in order to be able to simulate the production environment. So our application stack looks like that. We terminate SSL on Nginx. We use Varnish Cache, Apache, and MariaDB and MySQL and Memcached. Right. So that first thing I had back there, which talks about that little stack there of the many data centers. We have the 2 data centers. We use MPLS to distribute our VLANs across 10 gig infrastructure. We bought a dozen servers. So we had 2 machines which do the web cache, SSL, and the static content. We had 6 web app servers, 2 database servers, a dev and UAT machine. So each of those servers has, like the networking, it all has redundant power, it all has redundant networking. The servers are split between 2 data centers. Now, on Linux, you've got this really nifty thing called channel bonding, or Ethernet bonding, or port channel, or ether channel. There's a lot of different terminology for this on different network hardware. So on the Linux, you use the Bond 0 interface to group together a bunch of network interfaces. So, bridges, we all know what bridges are. You plumb your network interface into your VMs, the virtual network. So the VLANs, we've got a setup where we actually have 3 main VLANs. We have connect the web traffic to the web cache then talks to the web app server, the web app server talks to the database. So we've got those layers there. So we use QEMU, KVM and libvirt, and Virt Manager in order to manage all the remote VMs off your desktop. We've got some automation around VMs, but you know, we're still working on that stuff. Now, actually deploying stuff on your Linux server, this is the hardest part, is actually talking to your network people and making sure that you go through all of the steps, which is, this is what we want to achieve, this is the technical things we want to try and do, and this is the outcome. And in the university, it's a big, large organisation. There's lots of politics. So this was actually the hardest part, and probably the most important part because everyone knows what everyone's doing once you've had this negotiation, talked about it, and documented it. So under Debian, this is how you install all the tools for the VM running this stack. So VLAN, -slave, bridge utils, and obviously TCP dump for debugging this stuff. Etc. modules, AD21Q, and bonding of the two kernel modules you put in there, and that gives you the LACP negotiation to talk from your Linux server to your switch to give your channel bonding to work. No, sorry. AD21Q is the VLAN stuff. The bonding is the LACP for the Ethernet bonding. Right. Under Debian, you basically say, my interface is manually set up. And the reason for that, you don't give it any configuration because the reason for that is you then have the bond slaves and you list all the bond slaves. And so when the bond interface is brought up, it says I need to bring up all the Ethernet interfaces and then routes, enslaves those devices into the bond. And then the bridge interface. And this is perhaps the most difficult bit and the most underdocumented thing on the net. I spent quite some time messing with this. And the documentation for this is really bad. And if anyone's maintaining any documentation on any of this stuff, I'd like to give you stuff to put in there. The really important bit is this here. VLAN raw device is bond 0. So this bridge knows that it's talking to capturing all of the traffic out of that bond interface. And the bit where it says bond 0.1000 is 1000 is the VLAN number. So obviously this is just an example, but we have a bunch of these bridge examples on each of our bridge interfaces on each of our servers, one for all the subnets that we're plumbing around. And potentially you could have dozens and dozens of these bridges on your VM or your cloud servers. So once you've configured all that, you configure the switch to do the channel bonding at that end and route the traffic over it, reboot the server, and basically you end up with the VLANs piped up to the VMs. Now, right, so this is Virt Manager. Obviously people are talking about other things like Overt before, about there's web interfaces for this kind of stuff. This is running off my desktop box. I have a bunch of servers that I have the test and dev VMs on. Basically I run this up, fire up a bunch of dev VMs, do unit tests against web apps, making sure that each layer in that stack is working properly, my Varnish, web apps and database. And then, you know, turn that stuff off, you're happy with that, port stuff over to your UAT environment, your testing environment, get your users to test it, and then once you're happy with that, you push it into production. So, when you can configure your VMs, you have your NIC interface, your network interface for the VM, and up there you can see I've got bridge BR3443, and so basically you're selecting the underlying network interface on the Linux machine, the server underneath. So, and we use the hypervisor default driver, specifically under the QEMU because that seems to give us the lowest latency in terms of the network I/O. So we'll do everything else. Right. Questions?
Anybody?
One-word question. Performance.
Sorry?
Performance.
Performance. Okay. There's two main performance issues that we have. One of them is we've got the bonds transmit hash policy. So we've got 4 Ethernet devices in each of our servers. And so this policy basically says any IP and port combination that goes out the network interface is tied to one of those Ethernet channels. And this is a good thing and a bad thing. Basically it means you'll never get more bandwidth to a single VM than one Ethernet device. But it means is that that one VM won't impact the performance of everybody else. This is not ideal for a whole bunch of reasons, you know, like when you're moving around really big chunks of data. But for web interfaces, specifically web applications that we're running, it seems to provide us the lowest latency that we can currently configure with not affecting other services in that group of VMs running cloud services. So it's obviously it's QEMU under Debian on the standard kernel, so it's not amazingly fast in the big scheme of things, but it's far better than in all the problems we had with VMware originally. And the main reason that we had problems with VMware was where CPU was oversubscribed by about at least 4 times, 5 times on most machines. But the really, really big issue we had on VMware was our memory on all of the collective VMs was oversubscribed by more than 10 times. So we haven't ever faced the same issues that we had on VMware, specifically because we don't oversubscribe the memory on that for that machine. And we found that the VMs were spending 700 milliseconds to page in stuff from disk effectively because VMware was paging. So performance on this has been great, and the key thing is don't oversubscribe memory. Oversubscribe CPU, that's fine, because most machines don't do a lot of stuff all the time.
Just looking at your bonding policy, so layer 2 and 3, did you find that particular VMs ended up sticking to particular physical interfaces because of that, or you didn't sort of have any problems like that?
What happens is that an IP and a port number are bound to a specific device. So when you have a new, effectively yes. So what happens is the next request that comes in goes over the next device that's not currently being hammered. So the switch and the underlying server negotiate, this is the least busy connection, we'll send the new connection over that. So there's some smarts going on underneath the hood there which distributes that load. But the problem is that connection will stay there. If you have those connections continue to hammer away, you can saturate a single link, but for web services, most stuff doesn't last very long. The connection happens, a couple of 100 bytes, 1,000 bytes goes down there, it's done. The connection drops, goes on to the next one.
Out of curiosity, the stuff that you mentioned, the performance issues that you mentioned when oversubscribing memory,
yep.
Do those also apply when you use KSM, kernel same page merging, with QEMU on Linux?
Sorry, what was the last bit about?
KSM, kernel same page merging. Have you given any thought to that or used it?
No, I haven't.
No.
Cool. So thank you, Kim. That's all we have time for.